So we're just classifying these 4 reactions. Just putting the letters in the box. You don't have to write the whole thing. Remember, you've got 2 boxes on one side of the page, and then you've got 2 boxes on the back side of the page to sort these into. Is everybody good with these? Maybe not quite yet. I still see some people flipping back and forth. Emily, did you find which page this was? Is that what you're looking for? Yeah, it's just the page that has the boxes on it. And then we were putting the letters in the boxes. You got it? Yeah. Okay. And there's 2 boxes on one page, and you have to flip the other page to get the other 2. All right. Well, I'm going to help you out here because I just want to check everybody's thinking. So when we're looking at I, what kind of reaction was that? Synthesis reaction. We've got 2 elements coming together into one compound. J. What is J? Very good. Single replacement. We have an element and a compound. The element's stealing the other one's partner. So then we're left with an element and a compound, but it's a different element this time. How about K? It is a what? Just say it out loud. There you go. We got 2 compounds on one side, and we're ending up with 2 compounds on the other side, and they've just swapped partners. And L would be a synthesis. 2 elements coming together to form one compound. Very good. All right. So moving right along, I'm going to kind of zoom in down here. Now, I want to be real clear on this. The only type of reaction that we do this sort of thing that we're going to be doing right now is single replacement. Every time you see synthesis, decomposition, double replacement, or a new one that we'll look at in a minute, combustion, those reactions are always going to take place. Okay? For single replacement, we got to look to see, will this reaction even happen? Because elements are a little bit, you can kind of make them sound a little bit like people. Some elements are stronger, in quotes, than other elements. And really what I mean by stronger, I mean they want to grab on to another atom's electrons. If it wants to steal electrons from another atom and it's strong, it's going to actually kick the other atom out, steal its partner, and now we have our new compound. But elements, one element is not the same strength as another element. We got to look to see. Now, what I'd like to be sure that you guys have out is the periodic table that we picked up. I'll get you one, David, because you weren't here. We picked up the other day. It's got this on the back of it. You're going to need this reactivity series. You need to have that up, and you won't be able to see mine on the board all the time. So it says, look at the handout titled Single Replacement Reactions and the Activity Series. It says, in each reaction, the individual element is going to be shown in blue, and it's trying to replace the element in the compound that's going to be shown in red. Okay? Let me show you what we're talking about here. So here we have reactions that occur. You can see that we've got Ag in red, because it's in a compound. And we've got nickel that's trying to steal Ag's partner. It's trying to steal that NO3. Well, you can see that the reaction does occur. The nickel grabs the NO3, and Ag is left by itself. Everybody, does that make sense to everybody? These are all single replacement reactions. We're not going to be looking at anything else but those for this type of thing. So these reactions all occur. Now let's take a look at a reaction that doesn't occur. We've got Fe trying to steal Mg's partner. Mg is magnesium. Does it happen? You can see right here, it's no reaction. Iron is not stronger than magnesium as far as its ability to grab onto electrons. Okay? So really we're looking at is one stronger than another one. Now, you're never going to have to memorize this. Oh my goodness, even in college chemistry, you don't have to memorize the reactivity series. You'll have it right there in front of you. So this is the reactivity series. You'll see that we've got a metal section, and you look at yours too. Look at yours on your handout. And you can see that I've got a metal part, and then down below that, I've got a non-metal part. And we're going to talk for a second about metals versus non-metals. So if I'm going to look to see if a reaction is going to happen, I'm going to look at my two elements that are similar. Basically, they're going to both be on the same list. You're going to go over to the list, and I like to put an arrow. So I've got Ag versus nickel, Ni. Which one's higher on the list? Ni is. It's stronger, so this reaction is going to happen. It's going to grab the NO3. When I look at reactions that don't occur, here I have Fe versus, I almost wish I had one of those fight bells like in a boxing match, where it'd be like Fe versus Mg, ding, 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 ding. That'd be a great sound effects. So when you look here, and I'm going to again put my arrows there, here's Fe, and here's Mg. Which one is stronger? Mg is higher, so you can see there's no reaction. Fe isn't strong enough to steal its partner. All right, we're going to break things down. That's kind of it in a nutshell. But right for now, we're going to fill in that chart that you've got on your page. So and I'll do the first one with you. So reactions that occur, I've got Ag in red and Ni in blue. Now I'm going to look at these reactions that don't occur. Here's my blue one. Here's my red one. Mg, thank you. So there's your chart, and I'll kind of zoom it out so you can see the whole thing. All right. There, I think you can see them all. So go ahead and fill in that chart completely. When you're done with the chart, and again, when you look up an element, write its symbol down next to it on the list. It'll just save you some time. When you're done with the chart, you can actually go ahead and answer the next three questions. Ones that are in that boxes underneath them. Again, as you find you have to lift one up, just write a symbol down next to it, and be sure that you're looking on the metal and non-metal charts. Be sure that right here, these right here, be sure you're checking both this list and that little short list there too. With your chart, done with your chart, you're going to answer the next three questions that are based on the chart. our chart. And it says for each of the reactions, write down the element symbol of the individual element, the one that's shown in blue, and the element in the compound that's going to be shown in red in the tables. So we'll just do the first one. I'm just going to go over here. Ni was blue, and Ag was red. And then it says the highest element on the activity series. You guys look on your activity series. Which one is higher, Ni or Ag? Ooh, here's one thing. Your activity series has the element names on it. So what's going to be very helpful to do, when I say Ni, what element is Ni? Nickel, right? So right next to nickel on your list, I would write in Ni. So you never have to look it up again. You've got it right there. Ag is what element? Silver. So right next to silver, I would write in Ag. So you never need to look it up again. So for this one, which one was higher? You guys said it was Ni, right? All right, and that's how you're going to fill in this chart. Let me show you how you do the other part. The blue one was what? What was it? Fe. The red one was? I have to look back at that. Which one is higher? Mg is higher on my activity series. Fe stands for what? Iron. So next to iron, I would write in Fe. So you guys go ahead and fill in these charts. I'll flip back so you can see all the reactions. Fill in the charts. For this is for the reactions that occur. This is for reactions that don't occur. What is it? Iodine. Is it a metal or a nonmetal? It's a nonmetal, so I'm going to circle that. The element in the compound that it would be replaced would be what? Cl, because it's another nonmetal. So there's my one that would be replaced. So Cl is the one that would be replaced. Now I'm going to look at them on the activity series. Is the individual element higher or lower on the activity series? It's lower, right? So it's not higher, so no. Will the reaction occur? Will it recur? No. So we're just going to circle that or box it, whatever you'd like to do. I'm going to do the next one and give that as an example. What is the individual element? Ni. Is it a metal or a nonmetal? Metal. Very good. You got to look on the periodic table and see where it's located, and it's going to be a metal. The element in the compound that it would replace would be what? We've got this, and we've got that. What is it going to be replaced? The Ag, because this is a metal, and this is a metal. NO3, NO and oxygen, those are both what? They're both nonmetals, so I don't have to worry about those. It's going to compete with the Ni. So the one that's going to be replaced is Ag. Is the individual element higher on the activity series? Yes. Will the reaction happen? Yes. There you go. So you guys go ahead and do the next three. Now remember, you only do this with what kind of reaction? Single replacement. This is the only kind of reaction that you have to do this with. Everything else, whatever they give you, assume that it's going to happen and it's going to be fine. Single replacement is the only one you have to look at it. We've got one last little section to do, and it's very fast. And then the last little part you'll do on your own. And again, that's also very fast. So we'll be done pretty early. Please put your pencil down if you're done with all three of them. That way I know that everybody's ready to move on. Joshua, are you all done? Janae, you want to give him a nudge? Are you finished with all three of those questions? You guys must have eaten too much hot fudge cake. Hot fudge cake. There's a lot of people trying to nod off here. Again, if you could put your pencil down when you've got all three done, that way I just know that you're finished. Quentin, are you all done with all three? All right, I guess I'm going to move on. Looks like everybody's pretty much all set. So the last part, like I said, is really fast. The last type of reaction we're going to look at is combustion. That just means to burn something. So it says, look at the combustion reactions shown below. What's the same about the first reactant in all these equations? What's the same about them? Yeah, they all have, and C stands for what? Carbon. So they all have carbon and hydrogen. Now I'm going to move on to the next page. You'll have to maybe flip back and forth a little bit. What would you say this falls under? If I was going to classify this before we knew about combustion, what kind of reaction would you say this is? Is it a single replacement? Not really. We are starting off with an element and a compound, but you see in the products, the oxygen gets divided between the two things, so it's not a single replacement. Is it a double replacement? No, because it's got that one element. It really doesn't fit into any category that we've talked about. This is a combustion reaction. What do you notice about the second reactant in each of these equations? It's all oxygen, exactly right. And it's always written like this, O2. So oxygen is the second reactant in every single one of these. What do you notice about the first product in all of these? CO2. Carbon dioxide. What do you notice about the second product shown in every single one of these? It's all H2O, water. So when you're looking at a chemical reaction and you start to see carbon and hydrogen and oxygen are the reactants, immediately a buzzer needs to come off in your head and go, that's combustion. And then look to see you've got carbon dioxide and water, yep, that's combustion. Okay? It's a very special type of reaction that we give a special name to it. When we look at the last question says, combustion reactions involve burning. Which reactant has to be present for something to burn? Oxygen. When we throw water on a fire, how it puts the fire out is because the water coats the fuel and it blocks oxygen from being able to get to it. Same thing with the fire extinguisher sitting over there. We spray that powdery stuff all over our fuel. It blocks the oxygen from getting it, and it smothers the fire out. Okay? That's why a fire blanket works, because you're taking that blanket, throwing it on the fuel, blocks oxygen from getting to it, and now our fire goes out. Okay? Without oxygen, nothing burns. All right, next part is the last little thing that you guys are going to do. And you're just basically classifying the reactions, but here in these boxes, you're just putting, like, this is an element. Here we have a compound, and another element. So you're just putting C or E in the boxes for whether it's an element or a compound, and then you're saying the type of reaction that it is. And that's all we're doing, okay? When you're done with that, we're done for the day, okay? If you end up having to leave before you're finished, then just finish it up as homework. For everybody else, when you're done with this, I want you to flip back in your packet, make sure everything is filled in, okay? Yeah, everything should be filled in. If you need me to show you another picture, because maybe you missed it or I went too fast, I can, roll this back and let you see the pictures. So, and David, I would expect you probably need that. David, I expect you probably need me to roll back so you can see some stuff. Because we have a good chunk of time, if you've got something that you're looking at your progress report and you think that you're missing something, maybe you've got a task card thing to do. Janae, you're coming to mind. Yeah, we could take this time right now. Joshua, you had something that's missing. So let's just take this time, the last part of class, to kind of get some stuff made up that needs to be made up. But do make sure that your whole packet is finished except for the task cards.